Tjerk Timan and Mr. Steven Lefman from the Netherlands Organization of Applied Scientific Research. And Tjerk and Steven are going to talk about trustworthy AI in practice from high-level principle to data science practice. So I hand it over to you, Tjerk.
Great, thanks for the introduction. Stephen and I will talk a bit back to back on different cases, and we will have general interest in why ethics and technology. But before I share my slides, maybe it's good to, because then I lose all the visuals if I start my slides. I think it's good to have a kind of generic intro into what TNO is. TNO is what is called in the European research landscape an RTO, so a Research and Technology Organization, which means we do applied research in between TRL level. Well, if you know about this term, right? Technology readiness levels 3 and 7, roughly speaking. And we are based in the Netherlands by law. So we are we used to be a completely public institute, and now we are semi-public and semi-private, in which we actually say, okay, there is fundamental research that is happening in universities and in industry research labs, but how do we get that one step further? So we actually have a duty by law to give asked and unasked advice to government on all kinds of technologies, but also to help Dutch industry and society in all kinds of technology transfers, or kind of building a technology from an idea and a concept in the lab to upgrading that. And we do that in a lot of different topics, which ranges now. We're again in a reorganization, as always happens, but we for the moment have 9 units. So we're organized in units that cover topics from mobility to space to material science to healthcare to policy to data science to all kinds of topics. And basically the key source of income there is the 3 money streams that we base our work on. So first is the Dutch. Oh, that's really annoying! All the little ding dongs. So we get partially funding from the Dutch government to do particular tasks, and we set up a research agenda together, just like Europe does that in the Horizons. We have 1/3 of kind of contract competitive research, so Horizon Europe programs or European tenders or national funder, where we do a part of research and we do a part of competition, and we also have a part that is really business to business, where we just deliver a service or a particular technology to a particular sector. And we are 3,500 people and growing among different units. And Steven and I represent kind of 2 units that will be merged: strategy and policy, and ICT, which will be a kind of mid-sized unit that on the one hand does its own research, and the other so research in the IT domain itself, and on the other hand does a lot of research in applying those principles to particular sectors. And this is always a bit of a tricky topic that we'll also touch upon with AI, I think, in many cases. And so the IT domain itself is reinventing and needs to tailor to particular technologies and principles, etc. But also these technologies vary widely per sector where you apply it to. But we can talk about TNO later. I think it's a bit of a generic intro in what we do. So we are a not-for-profit organization, and as such we do a lot of research. We also do a lot of research into this topic of trustworthy AI, and that's what we want to talk about today, to say a bit what is the landscape, what are these kind of ethical principles, and how can you think about those from an engineering point of view, and then also go into some cases where we actually try to implement those principles with in use cases with actual real world partners that have real problems. So we're not only doing this in a lab, but we're doing this in reality as well. I'll share my screen, thereby I'll lose visibility, so you have to give me some auditive feedback if things go wrong. And we said that we will present first, and you can keep your questions till the end. If they're really urging, then you can barge in. But if you have more kind of generic questions, then let's try to tackle them at the end. We'll have time for that. I'll start from the beginning. Can you see the slides?
Yes.
Okay, perfect. So part one is actually a bit broader. So why are we talking about ethics, and why is this whole ethics topic so prominent in the area of AI? That's a question that we try to answer, and for that we need to go a bit more generic into why new technologies, and especially new digital technologies, cause so much headaches or so much concern. Why are we so worried about all of this? So that's a very a tricky question, but in general, what you can see is that, especially in the investment world, but also in the policy world, for instance, in the European context, we talk a lot about tech, and that's a bit of a strange word because it's actually often a euphemism for almost everything digital, and it's always linked to a kind of promise economy, right? So the next big thing after digitization was big data, and the next thing was AI, and the next thing is blockchain, and the next thing is quantum. And often these terms become things in themselves that are not really reflecting properly what the technology is, and sometimes that's also not really the point, right? So that is interesting to keep in mind, that also the AI hype has been a proper hype, but what can we see on the long term? What you see in this figure on the right as well. When does it become an actual productive technology? And we could say that we are now a bit in the peak of inflated expectations towards the trough of disillusionment, because applying AI is not so easy. And it's not a technology in itself, it's a set of techniques. Just as blockchain is not a technology, but an organizing principle, etc. So it's very important also from an engineering point of view to really demystify and untangle to non-engineers what is what, right? And that's what we do too little, I find. And there's, of course, the word tech is often used for digital technologies, but there's a lot of other technical innovations coming in other fields that happen as well. The interesting thing of digitization and, of course, AI is that there's hardly any scientific field now that doesn't work via digital tools or digital means or digital methods. So there also AI is having a huge transformational power on what kind of how science is done, basically, and that is interesting in itself to think about. So the horizontal transversal power of using AI tools to analyze genomes or to analyze material science, etc., etc. These, of course, are enormous fields in themselves where AI could be a key enabling technology, as we would call it. And what is also important to think about when we talk about emerging technologies is that who decides when something is emerging, right? And this used to be the scientists and the engineers and sometimes industry, but now, of course, we see more and more that it is investments. It's capital and big investments that decide what is now important or not, and that is something we need to be critically aware of. We're not going to go too long into this, but the term emerging is, of course, interesting because how long is something emerging, and when can we talk about something actually being there for the long term? AI has been there since the 50s, and so how long is something emerging? Well, we can say that there's a particular level where we can see it in day-to-day life and practices, and we can see it in particular industries used in operational context, that we can say actually it goes from emerging to actually being a technology that's just there. And what we often don't think about, on the one side you have emerging technologies, but the other side we have the phasing out of technologies, and that is something we also look into more and more to say, okay, but when can you divest out of something? But this is a bit broad. Let's not go too deep into that. But it's important to give this backdrop to also think about what is the question then of ethics, right? So what can ethics do to or with a technology? We've been talking about ethics for a long time before technology, and we've been talking a lot about ethics with the rise of kind of the Enlightenment and technological era in the last 2 centuries. And where's that field now, right? So there is a field that in itself is called philosophy of technology. That's interesting to look into because they've been dealing with these all kinds of questions for a long time. And basically the key question that they ask sounds very fluffy and in the cloud, but it's actually a very fundamental one. And that is, what is the good life that we pursue? And to give a very typical example or very concrete, if you go to AI, do we want to use computing power to calculate what is the best sweater to buy tomorrow, or do we want to use those resources to develop AI to predict the next potential flood? And who is deciding upon what is then a useful way of using a technology and what a good life is? And what you see there is there's different ethical schools, right? So the data scientists that I talk to a lot and the AI developers that I've been talking to, often without realizing they take a utilitarian stance. So they say there's a risk calculation, what's the benefit versus the risk, and if the benefit is greater than the risk, then it's a good thing, right? And this sounds logical, but there's a lot of backdrop and bad sides to thinking like that as well, because then you can calculate, well, we can kill 2 persons because it's better for the larger 10, for instance, or we can destroy this part of nature because it's better for business. So it really decides on who then decides these risks and how and who is making these calculations. And there's of course other schools of ethics as well. Deontological, which is really rule-based. Thou shall not. We shall not use AI to produce killer drones, for instance. That is not a utilitarian calculation. That is upfront. You say this is not what we're going to do. You can have virtue ethics. That is really about having the best example also in yourself. And so what is it that you as an engineer want to contribute to, and what are good examples that you would like to live by? And the other is kind of the care ethics that looks at what kind of relations are we interfering with when we're doing technological development in ethical questions. So that is interesting for AI, because in a lot of questions of AI and ethics, we see problems of bias, of fairness, where often the developing team never thought about who is actually using this technology or who is the victim of this technology, right? Who is being, which data profile or data point or data subject is being left out or is being disadvantaged due to these kind of technologies. And then we can talk about ethics of ethics, right? Which school to take, or is it a mix? That's something we can not going to go into deep now, but it's important to realize that ethical schools vary, and there's very, very different departure points in how you can think about ethics. And ethics is never a thing you do on a checklist and then you're done, right? Ethics is a constant. There's no one way also to say this is the good ethics and this is the bad ethics. It's a constant process. And what's also very important to note, which I notice a lot in discussions with data scientists and other engineers that conflate in this field the AI ethics. Ethics is not law, right? Law is something very different. Law is what we write down in rules, and it's a follow of this deontological rule-based thinking, but it's not deontology itself, and it's not politics either. So ethics is a different thing from that. So we should not conflate those. Of course, there's professional ethics. There's the Montreal code that you might know. So as an engineer field, you can say, we declare that we don't want to work on these kind of things when we do our work, for instance. And there's this very famous group about Timan that you might know, and the Google walkouts, where people said, if Google is going to do something for defense, we don't want to be part of it. Right? This is kind of the professional ethics that then comes into the AI field. Within technology itself, we see ethical standpoints translated in codes of conduct and COCs, standards or declarations. And the question is, how strong are these, right? How much do they do vis-a-vis the large kind of investment powers? This is something that you might know or might not know, but if we want to regulate a particular technology, there's different forces that work onto that. This I can come back to a bit later, because this is a lecture in itself. But the point is a bit that if you look at a thing, so in the dots you can put AI, for instance. There's market forces that work on that. There's law, written code that is working on that. We now in Europe have an AI Act that's coming that lays down legal rules on what you can and cannot do with AI. There's architecture or code, so there's the actual technological infrastructure that allows or disallows particular things, and there's social norms. What do we expect of a technology? What do we think is right? How do we feel, etc. And all these things have a force on how something is shaped and being regulated. And the question always is in this AI ethics field and the AI governance field is when and how to step in and via what methods, right? Do we let people in the lab build a complete system and then throw it into society, or do we need to intervene before? And what is then the right moment? Now that's always very difficult. If we then go to part two, to look at EU approaches to trustworthy AI, so what is the EU actually doing in this field? And I'll speed up a bit. Then you can see that, and these are probably known, that there's kind of 7 requirements that they put to say if we want to have AI in Europe, these are the kind of things, these are the 7 requirements that we need to adhere to. And we at TNO focus on a couple of those, not all, because it's very difficult, but they're all equally interesting, right? So how do you create human oversight? How do you make sure that the model is robust and safe and that it's not hacked? How do we deal with data privacy and data governance? How do we ensure that? How can we be transparent about these models to people who are not data scientists or engineers? How do we make sure that the algorithms are fair and don't lead to discrimination? We saw many cases of that in the UK and in the Netherlands as well recently. There's also an interesting one that is gaining more traction as we see now, is the societal and environmental well-being. So this is back to the example of where do you want to use AI for? We haven't tackled that question very well at the moment, but AI and algorithms take a lot of energy, and what do we find reasonable as energy resource to spend on AI, and who's deciding that? And the last one is something we are working on a lot actually within TNO, and that's accountability. So how can you on the long term audit AI systems, and how do you do that in kind of value trade-offs, in market trade-offs, etc., etc. We'll go into that a bit later. So as I said, so there's a couple of responses, right? So this response is the kind of the ethical response that Europe had to AI. There's also a legal response. There's an AI Act coming. There's a regulation that tries to aim at high-risk AI systems, and it's very muddy what exactly these high-risk systems are. There's a list, but it's a debatable list. And also low-risk systems on a large scale can have real harms. So it's a bit of a difficult discussion that is happening there now. But in the main idea is that there's going to be a list of forbidden AI applications in Europe. There's going to be a list of high-risk systems that you need to have very careful impact assessments for and risk assessments. And there's a level of low-risk systems that will not really be regulated. But this is a new regulation that cuts into the GDPR and into Data Act and all kinds of other stuff. So it's a big mess in Brussels at the moment to understand how all these rules kind of interact. And that's a very complicated story at the moment. And one of the main questions from industry now is liability. And so I train a model and I sell it to a company that puts their own data. And at some point, this model makes a mistake. Who is liable for this, et cetera, et cetera. So this is very, very difficult to decide the boundaries of what is that product then that is an algorithm or a system, et cetera. So that's interesting debates that happen now. The third response is market. So the EU is doing a lot of investment and horizon projects and all kinds of stimulus programs and networks of excellence on AI to make sure that against the US-based platforms and Chinese hardware, that Europe has another route or another chance to have a market in this space. And that's not easy because we lag 10 years behind of infrastructure and investments, but that is a third response that we see. And the fourth response is, of course, to say we need technological and by design solutions, right? So using technology to solve problems caused by technology, I always call that. So you see a lot of tech arms races now about detecting deepfakes or flagging bias online, etc. This is a big field where technology itself tries to improve the technology that is developing, and that's always a very interesting development as well, because that creates an entire market in itself. We saw that with privacy. You have privacy preserving technologies. That's an entire market in itself that tries to minimize the harms that has been created by the technology itself of big data analytics, etc. So that's a bit the question, and the question that we can ask ourselves as well in this lecture: is that enough to make sure that we make responsible and trustworthy AI? So departing from an ethical framework, to summarize, what is the good? It's hard to assess or check, but we need to define that. From public values, so what are public values and how can we capture those and better understand what is it that we want from this technology? What does the public expect from AI? Control via democratic institutions that are often lagging behind, not understanding yet what's coming. We have a law, so that's the third kind of departure point. What we wrote down are the rules, but laws need to be enforced, and that is very difficult as well. How can you cannot check every AI startup on whether they comply to all the rules. And then there's industry self-regulation and standards, codes of conduct, etc. So what do we do in this whole space? We do a lot, but basically we look at some key challenges. So what is now the current AI status and what is the future of AI? And more specifically, we do agenda setting in the EU level, from policy to practice. So we do a lot of analysis on actually where AI is being applied in particular sectors, what kind of policies are relevant in those sectors, what are kind of typologies of AI systems, is it really AI and what is it then? And we do that on a European level as well. So we influence, for instance, the AI Act vote with a particular study on what the effects are on public and private businesses. These kinds of things. We also do more practical research, so action research into co-shaping trustworthy AI via road mapping. So we do that on a European level. What are the key assets that companies actually need to build AI systems? We have an oversight lab that Steven will talk about. We have some ELSA labs. That ELSA stands for Ethical, Legal, and Social Analysis. And we also do a lot on orchestrating innovation, as it's called, and that is to say, how can you build ecosystems for a particular sector to really bring this technology a step further? And in this purple circle to the right, you can see a bit what kind of approaches we do there. And there we say, well, you need to co-create with you need co-creation methods. You need to demonstrate technically that your AI system is robust and that it works and that it's transparent and explainable. And there's a lot of needed in AI governments to really implement and scale it up. So how can you smart partner with big AI data centers, for instance? So how can you make sure that your AI system is usable outside of one setting? So now for some use cases, and I think I'll let Steven talk about one interesting one. We are focusing a lot of topics, but one that we wanted to point out is fairness and bias. And we'll skip this one and we'll go to the oversight lab. Steven.
Yeah, thank you, Tjerk. So indeed, in this framework of all these guidelines and governance practices coming for trustworthy AI, there are a lot of them, and we talk a lot with the public and the private sector, and they mention we use these documents such as the European Commission and also impact assessments to assess and discuss the questions that we need to ask ourselves. Make sure you're reproducible. There's a checklist. Are you biased? Are you explainable? Does the user understand? But what's really missing is to gauge whether your answer is enough, to really see how you implement it in your organization. And to tackle that, and not to make another checklist, in the AI Oversight Lab, we want to collaborate from the policy perspective to really understand these guidelines and what they really are aiming for, but also within TNO, the data science expertise, where I am positioned, where we then collaborate together with the public sector with actual use cases to learn what does it really take to go from these ethical principles that Tjerk has just shared about and to get it into your data science practice. We've finished one with the municipality of Nissewaard, and we have also this year worked on one with Immigration and Naturalization Service in the Netherlands, and one with the Human Environment and Transport Inspectorate. For example, they are using an algorithm to detect who is in social welfare fraud, and they have questions to us. Did we do enough? They came to us with the question, can we get your stamp of approval? And of course, we acknowledge that is not that simple. And in this handbook, we are trying to empower and use actionable storytelling for them to understand with a good example, this is how you have incorporated reproducibility throughout the AI life stages. And in this way, you have not, or here there's a risk that it's lacking. Within this handbook, we acknowledge these different levels within your organization to work on this governance, which for me as a data scientist, I translate as the rules and practices under which you organize yourself, that whatever you're doing is for the goals that you're setting. I hope that's good enough for Tjerk, as this is his expertise. And there you need to combine these insights from an institutional perspective, the policy and AI regulation that's upcoming, what you're doing in your organization with codes of conduct, the algorithm registries, but also within your team. What are the best practices that we share with each other? How are we reviewing our work together to ensure that we are doing the practice that gets to the goal that we're aiming for? So in this handbook, we go from the what you need to check to which roles are involved in actually operationalizing it, with examples of how it can go wrong and how it can go good, which of course is not that clear cut, but we dare to use our insights from actual use cases and transform it to a fictive use case to just show applied actions that you can do to operationalize this governance. Not striving for the complete, but striving for the useful. And to illustrate this a little further, I also showed the CeADAR use case. I think I can briefly mention a little bit more what we did there. They had this algorithm to evaluate, we were aimed to evaluate the algorithm that they had in use to detect the misuse of social welfare. But this municipality had all these social welfare recipients, and they wanted to steer the inspectors to investigate those recipients that were considered high risk by the algorithm. In the end, an inspector decided it, but they still got a lot of public criticism for using this algorithm. So they came to us, please evaluate it. And we said we're willing to do that in a research project where we focus on the lessons learned, because we also didn't want to say, oh, yes, with our approval, it will be good, either good or bad. We're learning this together. And they had 4 requests: robustness, transparency, data governance, and bias. The principles relate to those also shared by the European Commission that Tjerk mentioned. And we went about it. Let's just try to do it. Let's really learn this lesson. So we first started by what is the embedding of this algorithm, because we cannot do this by just looking at the piece of code and the outcome. So we did interviews with the municipality and also with the third party that actually created this algorithm. But there we got answers to, yes, we were robust. Yes, we are transparent. Yes, we have data quality. This is what we've done. And yes, we have this internal check for bias. But we also understood this is not enough for us to write our findings. So we went one step further to also look at the data and the code. First, also on the first level, what is documented? What are the methods used? How does the code look like? And there we went to beyond the technical evaluation of these concepts. Just as Tjerk mentioned before, you cannot look at bias or robustness just looking at the methods in the code and having an accuracy score. This is embedded with bias to the people that are affected. And also with robustness, that you actually show that changing from doing something random or doing something based on domain experts actually improves your process. And that's how we evaluated it and written down our findings and recommendations. So it was a learning by doing experience where we confirmed our intuition that this embedding is really important. And what ended up being the result, it's also public, so I can share with you, is their evidence of the effectiveness of this algorithm was anecdotal. They started using it. Instead of inspecting the 2,000 people for coffee, they just started inspecting the 10 that were suggested by the algorithm. And what happens, anecdotally, the percentage of fraud or misuse found was higher. But that's, for us, not a valid enough check for effectiveness in its own. But then we looked at the code. The code was not documented well enough. You had to, for software engineering standards, it was not good enough. And if you would rerun the code, so the first time you would run it, you get a top 10 of people you would have to go investigate. And this graph here below the process shows if you would run it 100 times again, how often would this top 10 be again in the top 10? What is the robustness even to just running the code again, not even changing parameters or sensitivity analysis, just rerunning it? How reproducible is it? And it showed that for many in the top 10, they would not be in the top. Even if you run it 100 times again, they would not come back again. So this is how we went from interview insight, yes, it's robust, to actually checking it and writing that lesson learned also in the handbook. That is, I think, what I would mainly add as an actual use case that what we have done. I can share more on another use case, but I first want to check with the time if we want to skip ahead, and we'll keep it for questions, I think.
You still have time, maybe 8 or 9 minutes. So
Okay, let's see. Because we have a whole list of use cases that we can talk about, but this one is interesting, I think, because it shows that there's a long way to go before you can even talk about assessing transparency or explainability. That and this whole robustness area, there's so much to do, where now a lot of AI is being services or systems are being developed and just put into practice without the necessary background checks. And this was really also for us an eye-opener, that we thought the quality would be higher, but it's not. And so this is another one I think that is interesting, discrimination detection.
Yeah, indeed, Tjerk. I forgot to mention that. We had the 4 aspects, but what we found, we couldn't go towards transparency or relevant bias research, because if it doesn't give the benefit that you're claiming, and you cannot even assess, even in the utilitarian perspective, if it's worth the risks, which you can never completely measure. But if you have no indication that it gives the effectiveness you claim, we had to stop there.
But I think that's a good point for a discussion. I think we have some minutes left, but so these are just some other topics that we could go into a bit further in the questions. So we do a lot on skills matching and the job market, which is very interesting as well, because there we see a lot of AI being used to automatically sift through CVs and make automated selections. And this is a very interesting field as well, because bias and discrimination is very under the surface, and there we also use that as a use case for looking into intersectionality. So you can focus on one type of bias, but what if there are combined variables or features that make sure that there's another type of discrimination that is often not seen in kind of singular bias testing things. So that's a whole new domain that we see a lot of work needs to be done. We also do a lot on explainability. So this is a project where we look at a kind of taxonomy of explainability. So what kind of explainability is needed in what stage and for whom, and what is technical explainability versus organizational explainability. So that's something that we're not going to go into deep to now, but this is an interesting work as well, because academically the topic of explainability is, some would argue, is kind of done, but in practice it's still a long way to go from what is academically there in explainability literature, also from the technical field and from the XI field, to actually doing this in practice. And that's what we're trying to do as TNO as well. And I think I just want to close off the last 5 minutes with some research agenda and discussion. So if you look at this whole field and all these values and kind of, we try to get ahead in doing action research and use cases to really learn from practice what is happening there. We see a couple of topics that are both on the agenda when it comes to trustworthy AI and AI ethics in practice from the ground up, and we see some from higher up. So from the ground up, we see a lot of interest and need for model robustness and uncertainty. So how can you actually, in the case that Steven talked about, if you're a municipality or if you're a company, can you make decisions operationally based on such a model? How can you, when is it robust enough that you can have operations run on it, right? And that connects to the next one as well. We see a lot of attention to lifecycle management, model drift, new data coming in, how often do you need to check it, etc., etc. And what I said before as well, and there's a lot of hype of AI, but we see in especially small and medium companies and organizations that they know that they have to or want to do something with AI, but they are looking for kind of proven cases where it actually adds value, be it societally or economically, right? So we need to also prove that actually it does indeed lead to less FTEs or less mistakes or better processes or better products, etc. And that is not always the case. And so there are some cases where this is clear and some where it's absolutely not. We see a lot of attention, and we also moving ourselves into regulatory sandboxing. So how can you prepare for this law that's coming up? And what do you need to do? So this whole handbook is actually a first primer for all kinds of organizations and companies to say, well, this is how you set up a responsible AI experiment. And we're just starting, but we think we have a good start. There's a lot of interest in human-machine teaming and collaborative decision-making in terms of trust. So how can you, in a team where you have some kind of situational awareness or an AI in the background giving you information, how can you make co-decisions? And what we're now doing actually as one of our main agenda points where Steven and I are also working on is really to get this handbook a step further and to continue with use cases in practice where we actually help data science teams and the organization around it to really build an operational AI systems, and then also to measure, does it actually prove some added value? And then some questions that we can ask. I don't know where all the bells are coming from. I hope not everybody's leaving or coming in. So the discussion we can have about this whole field is, and does AI actually yield new questions of trust, and where is that then based in? And so the picture on the right was interesting because I thought it was one of the first protests, public protests against an algorithm, which is interesting in itself. And there was an actual harm there, right? So how can we? What are the new questions, and are they really the result of AI? And then you can say, what is then trust? Is that a technical thing that you need to build in? Reliability? Is that societal? Is that in transparency and usefulness of AI? Is it institutional trust? Can we have institutions that make sure that we can trust these kind of systems? And a discussion is also, how do you trade off these values? Performance versus explainability, for instance. And the question that we also have is, can we get from experiments and research into operation to really show not only this utopian versus dystopian ideas of AI and all the potential risks, but actually see what is going on in practice to say something more detailed and sensible about this. And I think we can leave it here and have room for discussion. And we can also go into cases a bit more in detail if you want. And then I don't know if I can stop sharing. Do you see me again? I see you again.
Yes,
yeah. Good. So these are kind of the discussion points that I would bring forward. But of course, if there's any questions from the digital room on a use case or on other parts, then please go ahead.
Yes, so thanks Tjerk and Steven for very interesting talk and practical applications. So now we open for the questions. So you can either raise your hand and we unmute you, or you can put your question in the chat and you can read them out. I stop the recording now.